Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about new battery techs. So let's dive right into it. Now, first thing you have to understand, there is a lot of companies, as in like multi-million dollar to multi-trillion dollar companies that are pouring their money into it. So at this point in time, this is the next big thing. So think of this way, the primary reason for that is the vehicle market. Like, I mean, everything like from trucks to basically bulldozers, everything, they had reached a stagnation point. Basically, there is no longer any new company. And most company that you think of as company, like let's say Rolls-Royce, is just a brand. It's been bought by BMW, not the Rolls-Royce whole company. That money maker is at this point in time jet engines. So that division is out, but the car division, yeah, that has been sold off. So more than enough things that you think of oh, this are car company. No, they are just a brand bought by some other company. So car market has been saturated. Everything basically vehicular market has been like done. The end. You can't go into this market, you can't survive into this, you can't grow into this. It was done, dead, almost stagnant to a point. But at this point in time, because of the introduction of EV, because such a uncharted territory, that there is an actual probability that a new company like Tesla or Rivian or any other Tom, Dick and Harry company can come into this and survive, and not only that, also thrive and also become the next big thing. So this has opened a whole new get of like, entrepreneurs and startup people where like, maybe I become the next one, maybe I become the next Henry Ford, who knows. So that's the reality of it. The market is fresh, and that means a lot of money. Another aspect is green technology is taking over, as in solar, wind. Why? Money. They make money. Basically, solar at this point in time is almost at price parity with coal systems in cheap countries. Even in India, they're like, either you get your electricity from solar or you get your electricity from coal. It's almost the same. So what is the final limiting factor? Why can't we drop the solar price even cheaper than that? Well, we don't have energy storage. So at this point in time, the energy storage is like oil. Any company that figures out a technology that allows to make basically good energy storage, and I mean for either like just for one thing, like let's say this company only focused on like say making megawatt hour class batteries. They're like, dude, don't come to me if you want anything less than 1 megawatt hour. That's awesome. There is more than enough demand for it. Think of it this way: if you ever created a system that is like, let's say, few megawatt hour, every company will buy it at this point in time. Every person who has giant solar farm will buy it, every wind farm will buy it. So fundamentally there is like a demand is so high that it can be directly compared with the oil. Then we come to another aspect. Any company that cracks the chemistry part of it properly, basically milk that puppy, they're just gonna print money. They're not gonna be like, Apple has like $2 trillion evaluation. They're like, bro, please pitch, please. So fundamentally speaking, this is the next big thing, and fundamentally it's not like stock value. No, it is a real big thing. So we start with one new hype technology, that is blade battery. Now blade battery is basically rebranding of old technology, that is lithium iron phosphate battery. So what blade is focusing on, if you go to their site, they are like, okay, blade battery is safe, fireproof and all that jazz. It is, to a very large extent, it is very good. It is much safer than lithium ion and lithium polymer. However, lithium iron phosphate batteries, they are like yellow cells that people have been using for long enough. Heck, it has been used in Indian cars, as in like Mahindra Evo or original variant used that. So what's the big deal about this? Is like, if it is safer, why the heck not every company is using that? It does come with a consequence of lower energy density. So that simply means if you have, let's say, 10 liter of volume, it's like, put your battery into this 10 liter volume, how much oomph you can get out of that? That is much less compared to basically lithium ion or lithium polymer. So that creates a limitation, especially if you want to make very high performance. Basically you want to make a car that like embarrasses internal combustion engine. This is not it, because it itself has lower limitation. However, battery chemistry itself is just one part of the equation. So you can have a basically direction of a cell defines how quickly or how efficiently you can pack it into a package, basically your car. Like, if you can package it properly, awesome. If you can't package it, does not matter how good the chemistry is, if it's like wasting space, because that's the whole point of it. Like, normal cell is like stacked vertically, then it has like modules, then you have multiple modules, so you have a lot of wasted space. So what this company has figured out is like, not with magical technology and all that. They have a technology that has been working for long enough, but they figured it out such a way that they can manufacture long slits of it or blades of it. The idea with this blade, it will run across the whole length of a car. So that gives them multiple benefits. First is manufacturing wise is easy. Second, they do not need multiple small cells. Fundamentally speaking, chemistry wise, it's better to have one large cell than to have multiple smaller cells. So reducing the number of cells reduces the number of manufacturing steps and all that jazz. And because there's lithium, basically lithium iron system is fireproof to some extent. Again, if you actually set it on fire, it will burn, but it will burn like, it's just burning. It won't burn like it's adding to the fire. So that's good. So all these things combined, first the better stability and safety of the lithium iron phosphate design, and the better design of the blade, that's why it's called blade system. They're gonna achieve something amazing for practical car. Be very mindful, this is for every Tom, Dick and Harry wants, like, Lamborghini and Rolls Royce and all that jazz. Most people can't afford that. Now, most common selling car, this puppy is really good for that, because A, it's safe. That means your insurance and how much your money has to be spent to seal that puppy in, that goes down drastically. People feel safe about it, so they can buy it, and then it inherently is a cheaper chemistry. So that's why this approach is really unique. Now, be mindful, it is limited, but it is really good. It's something that you can see, your average Joe to use. It's not something like, I have, like, this Lamborghini embarrasser. It's not for that, but it's like for normal, for everyday use. This is awesome kind of technology and really innovative way of packaging the damn thing. Because like many times people are like, oh, I'm gonna make the amazing cell. How the heck you package it? That's very critical. Like, that's why Tesla is a Tesla, simply because they did not try to redo the battery packaging thing, and they just used 18-16-50. That allowed them to survive in the market. And if you're like, why other companies failed, that was the reason. They tried to make packaging structures that was so expensive that they could not mass produce it. They went bankrupt. So this is one approach. Then we come to the most annoyingly named thing, massless battery. Now you have to understand, this is 100% fake name, because massless only exists with photons. Everything else has mass. So what is this? Well, this is structural battery. So you may be like, why the heck these researchers did not name it what it exactly is? Well, you have to understand, structural battery is not a new thing. People have been trying this for last 10 years at this point in time. So there is a lot of bad name, because like, last 10 years ago, people were like, this in next 5 years, this will be the next big thing. 5 year came and 5 year went. So people are like, it did not pan out. So they rebranded it by calling it massless battery. It's not massless. So the idea is, frame of the car would be the battery. For example, right now you take a Tesla, you can literally strip it out. Like, there is a motor, there's wheels, and there is chassis, and then you have battery pack. The idea is you will not have battery pack, poof. So the frame of the system, as in roof, doors, panels, everything will become basically battery at this point in time. So you will not be able to find a spot where there's the battery. Oh, the chassis is the battery. It's almost similar to how aviation makes fuel tank, especially in commercial jet system. You have giant wings. Still in the older version, as in like 1970s and 60s, they used to have tanks inside those wings which used to carry fuel. But then somebody realized, what will happen if we create a sealant that is good enough that it can actually seal the wing itself and just flood the fuel into that? People started to do that. So that's what we call integrated fuel, wing fuel structure. So that's what they are trying to achieve. Basically, your structure of the basically cockpit, the monocoque, the chassis frame, everything would act as a battery. You will not have, I have battery here or engine here. No, the battery would be just the whole car. Motors you can have in the wheel or somewhere else if you need to. So that's the whole point of it. That's why they are calling it massless, because you won't have independent mass of the battery. However, be mindful, it will still be heavier than, let's say you have a structure, a pipe of this system versus a pipe of normal carbon fiber. Normal carbon fiber will be obviously lighter, simply because this basically they are utilizing carbon fiber so they can achieve the structural integrity needed, as in like strong enough. Now in past, people have tried to do with other stuffs, but they are always ended up in a point where they're like, it's strong, but it's not very weak electrically. It's electrically strong, it's very weak mechanically. So utilizing carbon fiber, they solve that issue, because carbon fiber allows a lot of gradual what you call pregnation of the materials, and they have figured out some clever ways of having negative carbon fiber electrode and positive fiber electrode, and then having separator structure, basically epoxy structure that is going to act as a separator. So they have built it. Like, this is a physical thing that has been built. It does work. However, it is very weak at this point in time and needs boatload of R&D. As in, this battery size, it's almost similar to what you have in your laptop or tablets, but this puppy can barely run a LED. That's why, like, you find a video footage of that, yeah, all they are lighting up is LEDs. So fundamentally, is this a good technology? Only in some cases where it may be useful, but most of the time, no, flat out no, simply because this is non-recyclable. Think of it this way, what happens at the end of a life, that matters, especially if you're talking about some large industry as cars. So cars, they have metal, you can just melt it, don't think about it. melt, done, go home. What can Tesla do? Tesla, all they can do is strip the car. They have the battery bank, they send it to a different factory that's gonna specialize in just managing the battery, and then the aluminum chassis, they're gonna remelt it. Tada! Carbon fiber is flat out non-recyclable, because anything that has fiber, basically you can't recycle a brick wall. That's the prime reason. Once you have something that requires two types of structure, basically paper, clothes, these sort of things are not recyclable simply because of that reason, because they have structures. Once you break that structure, it cannot be remelted. Metal can be recycled because it's you remelt it. Aluminum, you remelt it, you don't think about it. Glass, you melt it, don't think about it. Paper, not so. Carbon fiber, hell no. So that's the whole point of it. And in creating this sort of system only in scenario where it's like, no, I need this exact feature, I can see use of that, like aviation, some drones and all that jazz. But for car, this would be really bad for it, and not to mention idiotically expensive. So fundamentally, this is one of those technologies that had got rebranding, massless. Now then we come to the magic, the holy grail, the solid state battery. The idea is very simple. You have normal system where you have wet electrolytes and you have a separator, and because of the chemistry interaction, this battery is self-destructing. So fundamentally, the separator, if it malfunctions, it goes boom. So that's what happens whenever you hear news about Samsung Note going boom, or like somebody's vapor going boom. That's what's happening. That porous separator layer failing, and they're making love, basically anode and cathode are making love, and they are producing so much energy that's creating a literally runaway reaction, as in not only is gonna go boom, it's gonna make sure everything around it also goes boom. So think of this way, one cell has to be damaged in like whole Tesla, and it's gonna destroy the whole damn thing. So that's the problematic aspect of it. That's why like companies also engineer modules. The idea is the module chassis should be strong enough that one cell inside the module goes boom, it will basically set everything on fire, but it should be contained in the module. So basically that module should be compromised, not the whole car. So fundamentally, you're like, why the heck you want to have something that explosive? And the reason why I'm classifying it as explosive, it will work even underwater. So this is not something, oh, it cut off the oxygen, it will not work. No, it has everything it needs internally. So that's another aspect of it. So remove the wet electrolyte, change the chemistry, remove the wet from to solid. Now you have some improvements. Now, if you can figure out, because it is a complex chemistry thing, if you can figure it out how to make it solid electrode that has electrochemical property that you need, then you're gonna have some amazing things. For example, improved power density, meaning how many liters you need for, let's say, 1 kilowatt hour will go down. So meaning the volume, basically this is 10-liter battery, how much power this has, this puppy will have higher. That's awesome. Then we have lifespan, because the dendrite formation is almost negligible in this puppy, it's gonna last for much longer. So basically having a battery bank on a car that will run for, let's say, 15 years, this puppy can easily run for 50 years. So that's doable, that's awesome. Then we come to another aspect of it, it's very safe inherently. Even if you compromise it, as in like how lithium iron phosphate can handle being boomed, this puppy can handle being boomed. So basically you poke it with a nail, this is like, I got this, man. That battery will be shorted, but it can handle it, so it's not gonna go kaboom. So that's amazing aspect of it. Now you may be like, what's the downside? If it's like, it has a higher power density, it has a like longer lifespan, it has like more safety, what's the downside? It's just that there are at least 15 companies that have claimed it at this point in time. When I'm making this video, 15 companies, like be it Samsung, be it Honda, every company is like, I have figured it out, I have actually made this. Zero company at this point in time making, as in like around August 2021, nobody has figured out how to mass produce it. Be very mindful, we have built many amazing things in labs, but mass producing them is the main challenge. And so far at this point in time, nobody has cracked it. This is one of those things that are becoming almost like a running joke, like a fusion. It's like, and I'm copying this joke from some wise individual. Check the video down below. So reality is almost like, I have it. It's like there was a company that literally got sued because they made a button cell, basically cells that you use in your watch. That's how people generally experiment on things. You need to have hundreds of variants. You cannot not gonna waste your electrolytes on big cells. So generally they make button cells. They made button cell. It worked awesome, and they claimed it based on that button cell. It's like, we're gonna make a car in 2020. End of 2020, that's gonna have the better range than Tesla. So everybody's like, yo, awesome, the solid state, like, because the company was an actual chemical company, people believed it. And then like the stock value went to very high up. Somebody from investigation department is like, let me look into it. They're like, okay, you're claiming next year or so that you're gonna make a car, awesome, where's your cell? Like, physically show me the cell. Then they're like, yeah, this is the cell. And like, what the hell? When that part came out, it's like all they have built is the equivalent of a button cell. The stock value, then investors sued them. It's like, dude, if you are that far away, you cannot claim, oh, we're gonna build it in 1 year. That's not how it works. So that's the reality of it. At this point in time, every company has either patents on it or engineers on it, or like, I'm like 1 month away from manufacturing it, but it's almost the same thing for last 5 years. So solid state at this point in time is almost like a gamble. That's almost like fusion. Then we come to another aspect. Many times people have complained that my videos are very negative. They're not, they're very practical. Now, who's the final boss of this? Well, market. At the end of the day, you are not the boss, I'm not the boss, not the company's owner is the boss, nobody is the boss. The boss is the market. Think of it this way. Making claims in lab grade equipment, super easy. Any Tom, Dick and Harry can claim anything. Okay? That's just relax. Do not worry about this. So somebody say like, in labs we have achieved this. Does not matter at all. Don't even think about it. Don't even listen to it. If somebody says in lab, just let it go. Just let it go. Don't waste your time on it. Then sometimes people will get excited. Patents. Let me allow you to explain how stupid patents are. By the way, there are many patents on free energy, and this is a patent from Boeing. Now you're like, Boeing, big name, big stuff. This is a patent for laser fusion jet engine. Now you may like, wait a minute. Do we humans have fusion? Yes. Do we have fusion? No. What does that mean? That simply means we have not figured out a way to extract energy from fusion. So we can start a fusion, but we can't get energy out of it. So what does that mean? That simply means if you put 1 megawatt of laser energy into a spot and you have right fuel, deuterium and tritium, can you ignite it into fusion? Yes. Can you get energy out of it? No. That's why every single fusion reactor on the planet, as in from China to India to freaking USA to European Union, all of them are just fancy fusion light bulbs. They just glow. There is no energy out of it. Now, in that world, there are system what we call laser-based ignition system, laser ignition facility. Awesome. Laser can achieve fusion. We have achieved it. Here's the deal. Boeing is saying that. So you may be like, maybe. But here's the deal. That laser system that they need to achieve fusion is size of a football field. Basically, aeroplane will fit inside that football field. That's how big of the laser array they need to achieve fusion. And they're like, we're gonna have laser system here, we're gonna have laser system here. How the heck we are powering that laser system, or what kind of magical laser system is that? Who knows? And then we're gonna have a generator, then we're gonna have a turbine, and the turbine is gonna get something from somewhere, and it's gonna like, what? And how the heck you're gonna have radiation shielding? Because fusion, while it does not create radioactive waste, it does create GG amounts of gamma rays, as in really big G's amount of gamma rays. How the heck you're gonna protect your passengers? But there is a patent on it. So that's the reality of patent does not mean anything. You can just claim a patent on anything. And I'm really worried. It's like, what if in the future somebody actually figures it out, actually cracks it? They're like, yeah, we can't make it. They're like, why? Yeah, Boeing has patent on it. So that's the reality of it. You can make patents on things that you don't have. Another aspect is mass production is really hard. Like really freaking hard. Like think of it this way, Elon Musk with boatload of money, with GG amount of support from public, still cannot mass produce his vehicle at even half of the speed of what other car companies can do, even Indian car companies. That's how bad that is. Mass production is very difficult. Like I'm pretty sure somebody in Honda was like, when Elon Musk said, oh, I over automated the system, they would be like, you don't know how to automate a plant. If that happens, that simply means you do not know how to design a plant. Now again, that's understandable. Like Honda did not become Honda overnight. They spent decades on refining it. Every part of the process took years to manufacture it, mass produce it, refine it, learn from the mistakes. Then they reach a point where they can mass produce cars every few minutes or few seconds even. So again, Tesla will not gonna achieve that overnight. It's gonna learn the hard way. So at this point in time, even if you achieve mass production, be very mindful, you still have to understand the economics is the final boss. So you could be Apple, who can make a game console, and then the game console would flop. So that has happened, and you have to understand that economics is the final boss. Does it work or not? I don't know. You don't know. The company making it don't know. Only the market can tell that. And the primary driver behind that is economics. You could literally design this amazing thing. People may be like, I'm going to create a cheaper and crappier product that's going to destroy your, awesome product. It has happened. So be very mindful. Market is the final boss. Economics is the final form of the main boss. Now, if people want to understand, it's like, where would I put my money? It's like, what is the technology where I'm like, no, this technology can actually work. My money would be on Tesla's 4680. Now the reason for that is like, they have achieved mass production. At this point in time, all they are working on is improving the mass production. It's like, we have built it, it's actually in a car, it's actually working, it's actually meeting all the goals we need, and all we are doing is refining our production to a point where it's like, it's much better. So I can bet my money on that, because this does work. It does not require new magical technology that everybody has claimed to, but nobody has figured out. It's something that works. They have figured it, and that's what they were focusing on. They were not focusing on magical chemistry. They were focusing on how the heck we get raw materials out of it from USA itself, so we do not have to worry about tariffs, conflicts and all that jazz, and tax and all that jazz. Awesome. How do we mass produce it? So creating a, rather than wet process, a dry electrolyte processing, so we can, make this process much more efficient, reducing the water requirement. That's the amazing thing. They solved other things attached to lithium ion, not the lithium ion itself, and it yielded amazing result. Having that tabless design where they can have lot of thermal energy dissipation, so the battery does not overheat, and you can extract a lot of energy in and out of it without over damaging it. It's amazing. So, if my money has to put on something, it would be on this because it has already crossed all the lab patents, mass production, it has cracked it. At this point in time, it's only at the economic stage. So maybe in next 5-6 years we may see that 4680 become the next big thing. So this was my presentation on basically upcoming battery technologies. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.